Dear students, today we are going to discuss networking technology, particularly computer networking technology. And as a student of library science, you must be knowing that there are three, four very important facets related to a library, like your library automation, like your digital library system, virtual library system, institutional repository, archival management system, bibliographic databases. There are lots, and each of these, for their actual success of dissemination of information, depends a lot on networking. And therefore, as a student of library information science, you need to understand what networking is and what are the different kind of network available. How can we apply different, concepts of networking like TCP/IP, internet, intranet, extranet inside our library automation, digital library services and system. For example, let me give you one example, the benefit of networking. Suppose you are managing a library automation system and you are having 5, 6 staff. And if you are not connecting your 5, 6 terminal with each other at the back end of the library automation system like Koha or Lipsys or Sol, whatever you are using, then you're suffering for productivity loss. You are not allowing all of 6 staff member to work with that particular software. So there you need to establish the network between these 6 computers. Suppose you are having one printer, so you can connect that printer with that network, so anyone can throw a print job to that printer. You are having on a single scanner that can be attached with it. So a computer network is not only meant for networking computer. It can be done with your printer, with your other input devices like your scanner, your camera, and so on. So networking is very important to understand. Therefore, thereby you can provide lot of modern level library services to your users, and your users can access your library OPAC right from their home at 12 midnight because you are offering that service into 24 into 7 mode to a web server following a web architecture, and your data sets or library system ILS is connected to the network. Then only it is possible. If you are not having network, a digital library has no meaning actually. No one can access from remote site your digital library system. So who is going to care for your digital library? So the actual success of your system, what you have established, by burning lot of midnight oil, by sacrificing lot of hours and time, that a proper success will come through networking, through making those systems and services available to the greater number of people, greater number of end users through computer network. So with this brief introduction, let us now go for the technical details. As I said, a computer network, when we are saying it's not only a network of computers, you are actually connecting different kind of devices with it through some kind of proper arrangement. And proper arrangement, I do mean here a different kind of topology, network topology, what to follow, what not to follow, what is good for you, the type of network you want to establish, whether it will be a local area network or wide area network, whether you are offering that one over the internet. So that internet technology you can apply in your LAN, that is called intranet. If your intranet and external internet you want to manage through a firewall, that is called extranet. So a lot of these tools and techniques you need to understand, at least to talk to your different hardware supplier, your library automation vendor, and different other things, and to establish a proper secured library network in your workplace. So if we go to the type of network first, you all know there are three types: local area network, which actually meant for a building. Say for example, NSOU headquarter at Kolkata. They have a 5-story building, 5-story building. So entire there are lots of computers. So you are connecting all of this network in the same building through a network. That is called local area network. You are managing a particular campus, a particular building. Then comes wide area network through which we can go border. Suppose NSU has a satellite center at Kolani and headquarter at Kolkata. So these two centers need to be connected with each other in a computer network. They can use a wide area network. And generally, another very important thing is called wireless network. Wireless in local loop. Most of the cases to reduce our cost of networking, we go for the WIL technique. WIL technique stands for wireless in local loop. So most of the end user devices in a given network situation, like here in this NSU satellite center of Kolani, so there are a lot of devices can be connected to the main server through Wi-Fi, different kind of hotspot. So that is basically called Wi-Fi. So presently, nobody talks about metropolitan area network. It's a kind of LAN nowadays, or in case of a bigger network, it's a kind of WAN, wide area network. So these three are the most common types of network uh, in the domain presently. So what are the components of network that we need to understand? So network devices can be of two types. Either it's a end user devices or intermediary devices. End user devices can be your mobile phone, your computer, and so on. Intermediary devices are those devices which work in between two end user devices. From computer A and computer B, they are located in two different places, and their communication is actually based on different intermediary devices like switch, hub, router, and transmission media. Not only networking devices you also need transmission media. For example, as a teacher, I am taking class in a classroom. So my vocal cord is a source of information, and as a student your ear is a receiver of that information. So between the source and the receiver there must be a medium. So in a classroom that medium is ear. So in real life situation, computer network situation, that can be divided into two groups: bound link and unbound link. Bound link means two pointers connected with each other through a wire kind of thing. And unbound link means there is no wire connection available. They are communicating with each other in a separate kind of technology. If I give you example, you can understand that. So I already given you example of air as a media through which teacher voice is reaching to the earpiece of student. Similarly, in case of a computer network, when we follow bound link, we use three kinds of transmission media. It's a twisted copper pair. The data transmission rate is at the best kbps, kilobits per second. Then came coaxial cable. Data transmission rate is mbps, megabits per second. And finally, optical fiber communication. So in case of twisted copper pair, coaxial cable, there may be some kind of electromagnetic inference and signal may be disturbed. And twisted copper pair support only kbps, coaxial cable supports mbps, but optical fiber, as it is based on glass rod and principle is the total internal reflection, there is no interference from the outside, and it can achieve gbps speed, gigabits per second. So this is the bound link. In the unbound link we have satellite, we have microwave, and we have air for a classroom kind of situation. Then when your networking device is ready, transmission media is ready, are you able to do that? Not exactly, until and unless you have a protocol. Which particular protocol is actually communicating between two devices? So my vocal cord is tuned with your earpiece. That's why you are, getting it. As I am speaking in English language or Bengali and Hindi, and you understand that language, then only you can understand my, lecture. Same way, two communication devices can understand each other's data transmission if they are tuned in the same standard. like circuit switching, our plain old telephone system. So these are basically based on circuit switching. Then came message switching. You nowadays talk a lot about SMS, WhatsApp messages. These are basically message switching protocol. And finally, the entire internet is based on the latest one that is called packet switching technology or packet switching protocol, wherein suppose you are sending an email to your friend in US. So your email is first broke into number of packets. Each packet is having 53 bytes of data, and packet has got number. It's suppose your mail is divided into six packets. So 1 by 6, 2 by 6, 3 by 6, up to 6 by 6. All of these packets will be going through your gateway system, which is handled by a router. Router is a special kind of computer which sorts your packet by taking the IP address. Like a postal address, you are having your address. Your recipient has got a physical address. Similarly, in internet, everything is determined by IP address. We'll be coming to that. And packet switching actually send packets through router. Suppose in US there is again a router. Our router sends that packet to US router. US router reassemble that, and another protocol works there, and finally your friend can see that email. So a lot of things are happening in between this one, in between communicating this thing. And here in this graphical structure you can see what are the end user devices and what are the intermediary devices like hub, switch, router, gateways, and so on. So now if we come to the networking protocol, as I already mentioned about IP address, so here you can see the entire present internet communication or network communication is based on an open standard called TCP/IP. And TCP/IP is a suite of 21 protocols. And why it is then called TCP/IP? TCP is there, IP is there, HTTP is there, SMTP is there, POP is there. So 21 protocols it is happening, FTP, Gopher, and so on. But still it is called TCP/IP because TCP and IP, these two protocols are the largest and most important protocols in this software protocol suite. That's why it is called TCP/IP. The way we call UK as England, there are lots of other islands under UK, but England is the biggest island under the UK. That's why we call sometimes UK and England synonymously. Same thing happens here. TCP/IP is becomes synonymous with two individual protocol TCP and IP. So apart from TCP/IP, most often other protocol you must be knowing, that is HTTP, Hypertext Transfer Protocol, or HTTPS, Hypertext Transfer Protocol Secure. So in this way, network protocol works, and our entire global network presently based on an open standard TCP/IP. And you please remember it has got a set of 21 different protocols. Now TCP/IP, as I said, it's officially it's actually a 4-layer model, but some people also view TCP/IP as a 5-layer model for easy comparison with its mother protocol, that is OSI, Open System Interaction. So TCP/IP is actually originated from OSI, but OSI is a 7-layer model, very complex. So experts and computer scientists, network, scientists, they reduced OSI into a 4-layer model, which is called TCP/IP, and TCP/IP became much more famous and efficient in compare with its mother format, which is Open System Interaction or OSI reference model. So here in case of TCP/IP, you can see 4 layers are very visible and prominent. One is the application layer, another is the transport layer, internet layer, and network interface layer. The efficiency of TCP/IP achieved through its layer structure and functionality. And as I said, there are many protocols available, and there is a total of 21 protocols. Some of the common protocol TCP, IP, HTTP, HTTPS. Other important protocols are SMTP, Simple Mail Transfer Protocol, POP, Post Office Protocol, FTP, File Transfer Protocol, so on, all part of TCP/IP. So here you can see that, as I said, that there are 4 layers. Let us go for it, that which layer performs what operation. So application layer performs data formatting, particularly packet management, session management, and protocol implementation. Internet layer actually responsible for packet routing and logical addressing, fragmentation, so on. Network interface layer talks about framing, physical addressing, and if there is any kind of error, it can detect error. And transport layer is mainly responsible for segmentation, error detection and correction simultaneously, flow control of packets, and connection management. So this is in a nutshell what each layer does in TCP/IP. And as I repeatedly saying that TCP/IP is actually simplified protocol based on its mother protocol OSI. So OSI here you can see it's a 7-layer protocol, right from application layer to physical layer. So in TCP/IP, TCP/IP application layer actually combines or combines the application layer, presentation layer, and session layer of OSI into its application layer. So in this way, the 7-layer actually reduced to 4-layer. It became much more efficient, much more omnipresent. And nowadays, whenever you are seeing your YouTube videos, your Netflix, you are accessing a library dataset, every time you are accessing internet, you are actually using TCP/IP. And fortunately, this is an open model. Anyone can implement without paying a single paisa to any corporate agency. So that is TCP/IP, and that is the relationship between TCP/IP and OSI. Then comes another important concept which is called topology. Topology, it's not in mathematics. In case of network, it's a very simple kind of things how you are arranging your computer. And there are many different ways that you can follow. The simplest one is a bus topology. That means you are creating a line, a kind of information superhighway, and you are connecting your machine in that superhighway. For example, multiple USB mode. So there you are using that a single mode connecting to your computer, and lot of other USB devices you are connecting to that particular bus, that particular USB hub. So that is kind of bus topology. The same that kind of similar things is happening with bus topology. It's very simple, very cost effective, but there are limitations because you have limited number of device integration capability. Then come start topology. Most of the LAN network, local area network supports start topology, where at the central location there is a hub and switch, and all the computers are connected to that hub or switch. So it can be 8-port switch. That means you can connect 8 computers, 16 port, 16 computers you can connect. In this way, it can go to 256 ports, where 256 number of computers can be connected in a local area network. And here, the central role is played by this one, this switch or hub. That's why it is called a star-like formation. That's why it is called star topology. Slightly more costly, but it's very much scalable. You can increase and decrease number of devices, and it's a very popular in case of LAN formation. Then comes ring topology. You are suppose you have more number of machine, more than 256. So you are making a close ring of different switch and hub together, and each and switch and hub can manage another 256 number of computers. So you are getting a ring at the central and then different devices at the periphery. Same is the mesh topology. Mesh topology is the modification of ring topology, more powerful, more costly, and more complex. And tree topology is a very simple kind of hierarchical structure of organizing different devices. So in case of these topologies, three things are important. Generally, people follow start topology, ring topology, and mesh topology. So this is basically how you are arranging and organizing your devices in a local area network or wide area network. Then another important aspects of networking is security. So you need to understand network security a bit. First one is the firewall. So suppose when you are exposing your local area network into internet, every chance that malware, virus, and different kind of um, uh, what to say, different kind of malware, different kind of script will be you will be bombarded upon with those kind of malicious scripts. So firewall actually protects your LAN, makes your LAN secure to reduce that attack, to guard your local area network or your network against that kind of you know, malicious attack happened through different kind of viruses and malware. So firewall, next to firewall is the encryption. What is encryption? Suppose sometimes you go to a particular site, like your email site, you are entering your login ID or email ID, then you need to provide your password. So password, if you forward that password over the network in simple plain text, so anybody can fetch that data and can utilize your password for wrongful purpose. Same is the case with your payment gateway. When you are giving your PIN and many other things for online financial transaction, that PIN you cannot afford to send over the network in plain text. So there comes encryption. Encryption can be of different type. 128-bit encryption, 64-bit encryption. That means it is basically converting or camouflaging your, plain text password into number of jumbled character, and on the other side there is the key of that jumbleness, and the moment that jumble passes through the network and reaches to the other side, it unjumbled and your password is quite safe. Nobody can look into it, and if they can look into it, they cannot actually understand what is that password or login. So that is encryption. Then comes antivirus software. If your firewall fails sometime, some script or malware can, get rid of your firewall and comes actually to your computer. Then you need antivirus software to detect it, to quarantine it, and sometimes to delete it and to get rid of that particular software. So these are the, network security. These three things is very important, and you need to understand that why it is happening. So these are the trinity of network security, that you need to have an antivirus in your local machine. Your proxy server or your LAN manager must have firewall to reduce the attack, and your password protection and login and password must pass through network through some kind of encryption. So how computer networks and libraries are related with each other? Here you can see that network plays a very crucial role, that you are facilitating access to your digital resources over the network. Otherwise, there is no meaning to create digital resources, digital library system, if you are not able to go beyond your local area network. You must be global. Your presence must be global to provide your digital resources. That is data dissemination, information dissemination. Then enabling interlibrary loan and resource sharing, supporting different kind of online catalog like OPAC or access to your digital resource management system. So in a nutshell, you can see library network you can use provide access to your digital resources, to support interlibrary loan, to go for your web-enabled library management software or integrated library system, better communication with your end user, or through feedback, through different kind of other interactive facilities, so that your user can take part in your library activities. All is supported by computer network. So computer network is a very important thing. Now we are going to discuss this IP address and domain name system. So what are the different types of IP address? IP address, it's a unique address to identify a device in the network, and that device may be computer, that device may be a printer, device may be a router, and anything. It can be end user device, it can be intermediary device. Every device must be uniquely identified. Suppose you are searching Google from your phone. So how Google knows that this answer or this list of links against retrieved against your query is to be transferred to your phone, not into my phone? So there lies the concept of IP address. The moment your phone is connected, that phone has received an IP address for that session. That IP address can be permanent and can be changed over the sessions. So that's why if you go through this IP address, so some IP address are dynamic, session wise, like your mobile phone. Some IP address are static IP address, that means permanent. Suppose you are accessing your NSOU web server, you get different kind of forms, notification, and so on. So if every day they change their IP, if every session their IP is changing, then it is very difficult for you to as an end user to go there to collect information. That's why most of the web server follow static IP, permanent IP address, and most of the mobile devices, there is no meaning of giving static IP address, because you are only at the receiving end. You are not giving any information to anybody. You are not serving information. You are not serving data. So your is a dynamic IP address. So again, static IP address can be of again two type. You are using for a local area network or private IP address. No other people other than your local area network need not to know your IP address. For example, suppose I am running intranet in a local area network. So all of my connected machines are having static IP address or dynamic IP address, but that is known to my local area network only. This is outside people don't have any idea what is the IP address. So those are called private IP. And then comes the public IP. Like an institution, an university, like NSOU, a library must have a public static IP. So static IP they need, and that static IP must be known to the external world, and that's why it is called public IP, when IP is known to everybody. Then you see that IP address, as I explained, dynamic, static, public, private. At the core of the code, technically they can divide it into many classes. Class A IP address, class B, class C, up to class E. Generally, we use these three classes. Class A for big network, class B for a moderate level organization like a university campus, like Kollan University campus, we are following class B IP address. So two hosts we are having, two client we are having. So we can handle 256 into 256 number of computer inside our campus wide LAN. So this followed by medium size organization, and generally class C, which through which you can support up to 254 number of hosts people use in case of local area network, when local area network is based on internet technology, and when local area is applying internet technology like TCP IP, HTTP and so on, that we call intranet. So normally in case of intranet, small local area network, we use class C. For medium-sized organization like a university campus, we use class B, and bigger organization like a network service provider like BSNL or like different other commercial agencies, they follow class A IP address so that many computers they can accommodate. In class C, we can handle only 254. Class B, we can handle 254 into 250, around 65,000 hosts. And whether in case of a class A, we can handle 16 million hosts. And another, this is actually the category of IP4, version 4, which is basically a 32-bit address. You can see here an IP address version 4 is a 32-bit address, which is basically a combination of 32 1 and zeros bits, either 1 or 0. But that is very difficult to remember. So we convert that particular 32 bits into 4 dotted slotted decimal. Here you see 172.16.16.0. So there are 4 slots. This having 8 bits. This slot is having 8 bit, 8 bit, and 8 bit. So 4 into 8 bits, 32 bits. So we represent that in decimal format. Slightly easier to remember, but at the same time, how many this kind of IP address you can remember? For example, when you are saving your friend's number in your mobile phone, you save by name, and name is connected to the number. You do not recall the exact number. In fact, you can remember only a few numbers, like a very important number, like your home number, father's and mother's number, and so on. So rest of the people, your mobile phone number, you are managing a database, name related with this number. In same thing happens in internet also. We cannot remember more than 5 or 6 IP address in this fashion. So we use another kind of address called domain name system, where it's an alphabetical. We can understand what it is by seeing this alphabetical, because as a human being, we are more friendly with alphabets rather than number, whereas computers are more friendly with numbers rather than alphabet. So we developed an intermediary way. So where you can see, suppose This is the URL of your university NSOU. HTTPS is the protocol, then colon double forward slash is the separator, www is the host name, and here you can see this wbnsou.ac.in is called DNS, domain name system. And if you classify again this domain name system, wbnsou is the host name, AC is the sub-level domain because it's an academic institute and it belongs to the country India. So .in stands for CCTLD India. So here you can see this top level domain can be of two types. Either it's a GTLD, generic top level domain like .com, .net, .a2, any server from any country can register under it. And each and every country is represented by a two-letter alpha code like IN for India, PK for Pakistan, BD for Bangladesh, JP for Japan, FR for France, and so on. Actually, librarians first develop this kind of system to go for the uh, publishing country to describe. So later, this ISO adopted that standard as ISO 3166, and nowadays we have CCTLD, country code top level domain, which is .in here, then GTLD like .com, google.com, then ifla.org. So these are all global generic top level domain. And in between there is an ITLD, what inter country organization like UNESCO, like UNDP. They follow like UNESCO.ITLDD and so on. So this is international top level domain. Very few people, organizations are using it. Mostly these are GTLD and CCTLDs. And I already explained this domain name system, host, sub-level domain. Under .in there are various sub-level domain, AC for academic, RACE for research, CO for companies or commercial, Gov for government, and so on. So this is the domain name system. Now question comes that how IP address and domain name system are related with each other. They are actually one is to one kind of relationship. So in your browser you open and give the domain name like wbnsu.ac.in. So there is a root a server or name server which takes the domain name and checks this domain name is associated with which IP address. Then it connects to that IP address just like your mobile phone. You are calling your friend by name, but inside the network, your mobile phone converts the name into number, associated number. Number is actually valid in the mobile network. Same happening. You are giving domain name wbnsu.ac.in or for my case klyunip.ac.in. The corresponding IP address this root server gives to the browser. Then browser connects this IP address, and IP address actually established a connection between my client machine or mobile phone or computer or laptop to the server. Let me give you one example. Here you see, I ping your wbnsu.ac.in and response you see coming from a given IP address. So I given the domain name system. So that goes to the root A server. Root A server says that wbnsu.ac.in is associated with this IP address and response is coming from this IP address. So inside the computer system, your DNS is converted to IP address. IP address is the main thing. We can't remember IP address. That's why we represent IP address through domain name, and that is basically the how system works. So that's all for today in discussion. You can go through different kind of references I have given. Some of the basic books like Tannenbaum, you must read to know computer network in a better way.